A very good evening, children. This is 11th standard mathematics, chapter number 10, differential calculus. Problem number 16. And even in yesterday's class, we just discussed about the problems related with differentiation. A function will be given to us. We need to differentiate that function and find out the answer. That is what we are doing from the previous class onwards. Even today, we are going to differentiate a function which is given to us. So, differentiate, the function is this. We need to differentiate this and find out the answer. These are all the problems which gives us practice to differentiate various types of functions, so that we may familiar with differentiation. How to differentiate, that is what we are learning through these problems. So, this is the function, you know very well, this is cube root, right? 3 means cube root of 1 plus x cube. That is how we have to read this. So the function is y is equal to, I am writing this as 1 plus x cube. Instead of writing cube root, we are writing power 1 by 3. So cube root is replaced as power 1 by 3. If it is square root, then we will write power 1 by 2, fourth root, power 1 by 4, etc. So here, since it is cube root, we are writing 1 by 3. Power is 1 by 3. Now, since we need to differentiate, we are differentiating this with respect to x. So y becomes dy by dx. We have seen this in the previous class itself. Differentiating y with respect to x means it will become dy by dx. This is equal to, use x power n formula. So n into x to the power of n minus 1. I think by now you should be familiar with all the basic differentiation formulas. So immediately you should be able to understand what I am telling. So power comes forward 1 by 3, power gets reduced by 1. So what we are doing, applying x power n formula. Suppose just I want to write the formula in the left column. We are using the formula as x power n. The formula is n into x to the power of n minus 1. This is the formula that we are applying. But in place of x, we are having 1 plus x cube. In place of x, we are having 1 plus x cube. In that case, what we have to do, we should differentiate this once again. So just apply this formula. So n into x power n minus 1. We should not stop there itself, because in place of x, 1 plus x cube is present. So we have to differentiate that once again. Differentiation of 1 is 0. Differentiation of x cube, answer is 3x square. So we should not forget to write 3x square. Now 3 gets cancelled. X square into 1 plus x cube. If you simplify this, that is cross multiply. 1 minus 3 by 3, which is minus 2 by 3, which is the answer. Some look simple, but how to apply the formula we should know. We are applying x power n formula, but in place of x, 1 plus x cube is present. So after applying the formula, we need to differentiate 1 plus x cube once again. So 3x square comes. 3 cancels, remaining is the answer by simplifying the power. Problem number 17. Differentiate capital F of x is equal to, this is the function given, x cube plus 4x to the power of 7. So like we did in the previous sum, first write the question f of x. Now differentiating with respect to x. If it is y, it becomes dy by dx. If it is f of x, it will become f dash of x. What is the meaning of putting dash? We are telling that we are differentiating f dash of x equal to, again apply the same formula. What formula? X power n formula. X power n, if you differentiate, what is the answer? N into x to the power of n minus 1. So this is the formula that we are applying, x power n, n into x power n minus 1. So power comes before, power gets reduced by 1, so 7 becomes 6. But you should know that in place of x, we are having x cube plus 4x. We are considering this as x. So in place of x, some other term is present. So what we have to do? Differentiate this once again. So x cube differentiation 3x square, 4x differentiation 4. So extra this term should definitely come. Applying the formula x power n, where x is, we are assuming x as x cube plus 4x. So we should definitely differentiate this once again and write in multiplication. So this is the correct answer. If you stop here, it is wrong. We should differentiate this once again, because in place of x we are having x cube plus 4x. So differentiating this once again, we should write this. Problem number 18. Differentiate y is equal to cos of a cube plus x cube. Again, in this sum we are going to apply the formula. The formula that we are applying is the differentiation of cos x. Can you guess what is the answer? Differentiation of cos x. What is the answer? So when we differentiate cos x, the answer is minus sin x. What is the answer? Minus sin x. So minus sin x is the differentiation answer for cos x. So same thing, differentiating with respect to x, y becomes dy by dx. This is equal to cos x. So you have to assume this as x. We are assuming this as x. So answer is minus sin x. So minus sin, this is x. So we are writing that minus sin x. Again, we should not stop here itself, because in place of x we are having a cube plus x cube. In place of x we are having a cube plus x cube. So we need to differentiate this once again. A cube is constant. So constant, if we differentiate, becomes 0. X cube, if we differentiate x power 3, the answer is 3x square. Yes or no? Differentiating a cube 0, x cube 3x square. So final answer is minus 3x square sin a cube plus x cube. What is the formula? Cos x formula we are applying, minus sin x. So minus sin x. In place of x this is present, so differentiating this once again, 3x square comes. So final answer is this. Hope you will understand. Problem number 19. Problem number 19. Differentiate f of x is equal to x by root of 7 minus 3x. So we need to differentiate this function. So this is the question given. Differentiating with respect to x. What is the formula that we are applying? U by v formula. You see, this should be considered as u and this should be considered as v. What is the formula for u by v? U by v differentiation formula, v into u dash minus u into v dash divided by v square. So this is the formula for u by v. So if you see, v into u dash minus u into v dash by v square. What is u? Numerator. What is v? Denominator. So differentiating, f of x will become f dash of x equal to v. What is v? Denominator. So writing that u dash, u means x, u dash means differentiating x. Differentiation of x is 1 minus u, u means numerator, x into v dash. V dash means we need to differentiate the denominator. That is the meaning for v dash. Differentiating this, you know very well, square root means power 1 by 2, right? Square root, the meaning is power 1 by 2, or I will write here root of 7 minus 3x can be written as 7 minus 3x to the power 1 by 2. Yes or no? So just imagine this. Now differentiate this. Power will come to the front. So 1 by 2. Power gets reduced by 1. So 1 by 2 comes front. And power 1 by 2 minus 1 gets reduced by 1. Since in x place we are having 7 minus 3x. Differentiate 7 minus 3x once again. So minus 3 comes. Because if you differentiate 7, answer is 0. Minus 3x differentiation is minus 3. So this is v into u dash minus u into this entire thing is v dash. What formula we are applying? X power n, n into x power n minus 1. But in place of x this is present. So differentiating this again, 7 becomes 0. Minus 3x, if you differentiate, answer is minus 3. By denominator v square. What is v? root of 7 minus 3x. So when we square and square root will get cancelled. So 7 minus 3x present. Now here writing this as it is, if you see minus into minus, minus into minus becomes plus 3x by 2 into 7 minus 3x. Simplifying 1 by 2 minus 1, answer is minus 1 by 2. And next step, f dash of x is this plus 3x by 2. Writing this in denominator, we know very well minus 1 by 2, when we write that in the denominator, it becomes plus 1 by 2. Yes or no? 7 minus 3x to the power of minus 1 by 2 can be written as 1 by 7 minus 3x to the power of 1 by 2. So when it is written in the denominator, the minus sign will go, so plus sign will come, plus 1 by 2. Plus power plus 1 by 2 means square root, that is the meaning. 7 minus 3x power 1 by 2 is written as root of 7 minus 3x power 1 by 2. Instead of writing power 1 by 2, we can write root of 7 minus 3x. So bringing this to denominator, this comes. Now taking LCM, so this gets cross multiplied. Root 7 minus 3x into root 7 minus 3x becomes 7 minus 3x. 2 is here, plus 3x divided by, again 2 root 7 minus 3x will come as LCM. Already 7 minus 3x is present. So by taking LCM, that is by cross multiplying this to this, by cross multiplying and adding, we will get this step. Because LCM is 2 root 7 minus 3x, it comes in the denominator. Already 7 minus 3x present, that we are writing here. So now bringing this inside, 2 inside, 14 minus 6x will come, right? 14 minus 6x plus 3x will become minus 3x. By this is the final answer. So this differentiation is based on the formula u by v. What is the formula for u by v? V into u dash minus u into v dash by v square. By using this formula, we are doing like this. Problem number 20. Question number 20. Differentiate y is equal to 5 power minus 1 by x. So if you see this, power carries variable and the base is a number. In this case, we are going to use the formula that we learnt in the beginning. Differentiation of a power x. The answer is a power x log a. This is the differentiation formula that we know, where a is a constant. Now see, here 5 is constant, power is nothing but variable. So writing the question once again, differentiating with respect to x, y becomes dy by dx, and a power x formula is a power x log a. So a power x, we are considering this as x. So a power x log a is 5, so log 5. But in place of x, we are having minus 1 by x. In place of x, we are having minus 1 by x. If it is like that, we should differentiate this once again. That is what I am stressing in all the problems. In place of x, if some other term is present, use the same formula but differentiate that once again. So 5 power minus 1 by x log 5. We should not stop at this. We have to differentiate this minus 1 by x once again, because in place of x, minus 1 by x is present. So how to differentiate minus 1 by x? 1 by x, if you differentiate plus 1 by x, the differentiation answer is minus 1 by x square. These are all the basic formulas we studied at the beginning of this chapter. Once again I repeat, the differentiation of 1 by x, answer is minus 1 by x square. So what happens if it is minus 1 by x, the answer is plus 1 by x square. So when we differentiate minus 1 by x once again, the answer is plus 1 by x square. So combining everything, we are writing 5 power minus 1 by x log 5 divided by x square. This is the final answer. Which formula we are applying? A power x. A power x answer is a power x log a. But in place of x, minus 1 by x is present. So again differentiating that and writing the answer as plus 1 by x square. Problem number 21. Differentiate y is equal to e power x cos x. So writing the question, differentiating with respect to x, y becomes dy by dx. Now the formula that we are going to apply here is e power x. When we differentiate e power x, again the answer is e power x, right or not? This is the formula that we know. So we are comparing this and this, e power x. So we are assuming this entire thing as x. This power, entire power, we are treating that as x. So applying the formula, we will be getting the same answer, e power this thing. But in place of x, x cos x is present. So we need to differentiate x cos x once again using uv method. So what is u? X is u, cos x is v. So u into, what is the formula for uv? U into v dash plus v into u dash. So e power x formula, when we apply, the answer is same, e power x, but in place of x, x cos x is present. So differentiating x cos x once again using uv formula. This is u, this is v. So u into v dash, cos x differentiation is minus sin x, plus v into cos x into differentiation of x is 1. So cos x into 1. So e power x cos x, first I am writing this positive sign is there, so writing this first, cos x minus x sin x is the final answer. So the concept that you should understand is, when we apply a formula, if in place of x, if some other term is present, we can apply the same formula, but we should differentiate the term which is present in place of x once again. In place of x, x cos x is present. So we should differentiate this x cos x once again. That is the important concept that you should understand. Question number 22. Differentiate y is equal to sine of tan of root of sin x. So it looks a little bit difficult. Y is equal to sine of tan of root of sin x. We need to differentiate this. Understand carefully. So writing the question once again. Differentiating with respect to x, y becomes dy by dx. So first formula that we are going to apply is, when we differentiate sin x, answer is cos x. This is the first formula that we apply. First formula that we are applying is sin x differentiation is cos x. So sin, this entire thing is considered as x. So what is sin x formula? Cos x. So cos, this entire thing is x. So cos x, but we should not leave as it is. In place of x, this is present. So differentiating this once again, what is the differentiation of tan x? Secant square x. Tan x differentiation is secant square x, but what is x? Root sin x. First formula is sin x differentiation cos x. Differentiating this once again. Tan x formula is secant square x, but in place of x, root sin x is present. So differentiating root sin x once again. Root sin x, if you differentiate, the answer is 1 by 2 root sin x. But that is the formula for first formula we applied is sin x formula. Second formula that we applied is tan x formula. Tan x differentiation is secant square x. But in place of x, root sin x is present. So the third formula that we applied is root x differentiation is 1 by 2 root x. This is the third formula. If you see, 1 by 2 root x. But again, in place of x, sin x is present. In place of x, sin x is present. So we should differentiate the sin x once again. What is differentiation of sin x? Cos x. So continuous successive differentiation. Now see, first sin x. So cos x. Differentiating this once again. Tan x formula, secant square x. But x place root sin x is present. So differentiating root sin x using this root x formula. Root x formula is 1 by 2 root x. So 1 by 2 root sin x, but in place of x, sin x is present. Sin x differentiation is cos x. So writing everything now. Cos of tan root sin x into secant square root sin x into cos x by 2 root sin x. Try to understand the concept. It is very important. Problem number 23. Find the derivative of y is equal to x cos x power cos x. Find the derivative of y is equal to x to the power of cos x. Now if you see this, base is also a function, power is also a function. Base and power both are functions. If it is like this, definitely we should do the problem only with the help of logarithm. When if the base and the power both are functions, then we have to go and get the help of logarithm. So what we are doing is taking log on both sides. So both sides we are taking log, and using power rule of logarithm, this power will come to the front. So cos x log x. Now there is no power. So now I am differentiating with respect to x. Log y, what is the log x differentiation formula? If I write log x differentiation formula is 1 by x. Now see, log y, 1 by y. But what we are doing is we are differentiating with respect to x. So here there is no x, only y present, but still we are applying this formula. Log y means we are writing 1 by y. If it is log x, we will just write 1 by x, that's all. But since log y is present, after writing 1 by y, we should not stop, because in place of x, we are having y. In place of x, we are having what? Y. So what we have to do? Differentiate y again. So when you differentiate y again, what you will have? Dy by dx. Again I repeat, log y 1 by y, but in place of x, y is present. So differentiating y again, dy by dx. So log y differentiation, what is the answer? 1 by y dy by dx equal to, here we should use uv method. This is u, this is v. So u into v dash, log x differentiation is 1 by x, plus now keep log x as it is, v into u dash, cos x differentiation is minus sin x, right? So now how to commonly write this? Find that question is find the derivative of, which means we need to find only dy by dx. Keep in your mind, find the derivative of, this means we need to find dy by dx. So I don't want this y to be present here. So cross multiplying this y to the other side. So it will become y into this entire thing. Cos x by x minus sin x log x, right? Cos x by x minus sin x log x into y. So that is what we are going to do. Cross multiplying this y to the other side. So see, cross multiplying y and writing this. What is y? It is given in the question. Y means x power cos x. This is given in the question. So substitute that y means x power cos x into this. This is the final answer. So we will see one more similar type of problem. Find the question number 24. Find the derivative of root of xy is equal to e to the power of x minus y. Again writing the question once again. Now if you see, again there is a confusion. Function. So what we have to do? Take log on both sides. So log, writing the square root as power 1 by 2, xy power 1 by 2 equal to taking log on both sides. So log on both sides. Power rule 1 by 2 comes to the front. Power rule x minus y comes to the front, right? So half of, using product rule, log xy is split as log x plus log y, and here we know log e, answer is 1, because log e base e, answer is 1. So this becomes 1, only x minus y remains. This becomes 1, x minus y remains. Cross multiplying this 2 to other side, so 2x minus 2y, this comes. Now everything is a normal. So now we are starting the differentiation. Differentiate with respect to x. So far we haven't done any differentiation. Just we took log on both sides and simplified. Now only we are differentiating. What is the answer for log x? 1 by x. When you differentiate log x, answer is 1 by x. Plus log y, we are differentiating with respect to x. So what is the answer for log y? 1 by y dy by dx. Don't forget to write dy by dx, because we are differentiating with respect to x. Log y, answer is 1 by y, but in place of x, y present. So differentiating y once again, dy by dx equal to, if you differentiate x, 1 will come. So 2 into 1, 2 minus 2. If you differentiate y, it becomes dy by dx. So writing this first, 1 by y dy by dx, and bringing this to other side. Minus term comes to other side, plus 2 into dy by dx equal to 2. 1 by x comes to the other side, minus 1 by x. What we actually want to find the derivative. So we want dy by dx. It is present in both the terms. So what we have to do? Take common. take dy by dx as common from these two. What happens? 1 by y plus 2 will remain, right? So taking dy by dx as common, remaining is written, and here it is LCM is taken. Here also take LCM, just cross multiply this. So 1 plus 2y by y equal to this. We want dy by dx. So writing this here and just taking this term to other side. So y comes to the numerator, 1 plus 2y comes to the denominator. So final answer is dy by dx equal to y into 2x minus 1 by x into 1 plus 2y is the final answer. We will see one more sum of the similar type. Problem number 25. Find the derivative of x power y equal to y power x. So this is the question. Variable, variable, power also variable. So what we have to do? Take log on both sides. So power comes to the front, y comes to the front, x comes to the front. Since everything is normal now start the differentiation. Differentiate with respect to x. UV method, this is u, this is v. So u into log x differentiation 1 by x plus v into y differentiation dy by dx equal to, right hand side is also uv method, u in v. So u into log y 1 by y dy by, this is v dash, plus v into log y into differentiation of x is 1. So both sides we are applying differentiation uv method. Now see, log x dy by dx, another dy by dx is present in the right hand side, so bring that to the left hand side. So minus comes, minus x by y dy by dx. If you see right hand side, log y remains, y by x comes to the other side, minus y by x. What we want actually, dy by dx, which is present in the two terms. So take dy by dx as common from these two. What happens? Log x minus x by y remains. So taking dy by dx as common from these two. So dy by dx is taken as common, remaining is written. Now LCM. If I cross multiply, what happens? X log y minus y by x. Here also you take LCM. Y log x minus x by y. Now see, just take this to other side because we want only dy by dx. So dy by dx is equal to, just take this y to here. So y into this divided by, already x is present. This will come to the denominator, which is the final answer. Problem number 26. Find the derivative of cos x power log x. Since no name is given for this function, we are giving a name. Let y is equal to this. Since base, power both are functions, take log on both sides. So log y, here also log. Using power rule, log x will come to the front. So using power rule you will get. Now everything is in the base. Start the differentiation. Differentiating with respect to x. What happens? Log y, you know very well, log y differentiation is 1 by y dy by dx equal to, this is uv method. This is u, this is v. Now see, keeping u as it is, differentiating v. What is log x differentiation? 1 by x. Log x, answer is 1 by x. But in place of x, cos x is present. So differentiating this once again, minus sin x comes. Plus, now we kept u, we differentiated v. Plus v, just keep v, that is log cos x. Differentiate u. What is the differentiation of log x? 1 by x. Now what we want actually? We want dy by dx. So dy by dx equal to, just take this y to other side. Y into minus log x sin by cos is tan x plus log cos x by x. What is y actually? Cos x to the power of log x. Substitute that, cos x to the power of log x into, since positive, this is positive term, writing that first, log cos x by x minus tan x into log x. So this is the answer for the derivative. Dy by dx answer is this. Hope you will understand all the sums. These final 4 sums are of same type. What? Base and powers both are functions. So how we do? Take log on both sides, bring the power to the base and then start the differentiation. Use appropriate formulas and get the answer for dy by dx. Find the derivative means in all the problems we are trying to find out the value for dy by dx, right? Hope you will understand. These are all important problems. So write and practice. Thank you, children.